There is no truth to the allegations that statisticians are mean. They are just your standard normal deviates. And speaking of standard normal deviation, we are going to use that as a ruler to measure things. So IQRs are great if you want to know what the middle spread of the data is. If I want to know the middle 25% on the lower end and then the 25% right above the average. But most of the times that's not good enough. What if we want to know if a point is more far away than we expect, which is a lot of what we're looking at, or maybe what percentage of data falls between 2 points. So I could actually say, okay, what percentage of my students should I expect to get between an 80 and a 90 on a test? So for normal distributions or nearly normal distributions or approximately normal distributions, we can use what's called a relative measure. And this is what we use, the number of standard deviations away from the mean. And this number of standard deviations away from the mean is something we call the z-score. So you're going to have data that is more or less than one standard deviation from the mean. So we're going to figure out what that number should be. And the z-score measures how many standard deviations that point is away. And there's a formula on your, actually this is not on your AP math chart, so you should memorize this, but it's not real hard. Basically, the z-score is take the distance between the mean and the point and divide by the length of the standard deviation. If z is less than 0, the point is below the mean. If z is greater than 0, the point is above the mean. Let's revisit this cool app where we can see the actual data live and how the numbers change. So here we are with my points, and before we looked at the difference between the point and the mean. So if the point was lower than the mean, the difference was negative. If the point was higher than the mean, the difference was positive. Now to find the z-score, all you do is take this value, in this case negative 6.6, and divide it by the calculated standard deviation. So 4 goes into negative 6.6, negative 1.65 times, roughly. I'm sure it's rounded. And as I move it around, so if I take this point and I move it further below, what happens to the z-score? It goes down, right? As I move it up and it gets closer to the mean, the z-score is getting closer to 0, becoming closer to positive until I get to the other side. And you can see that the z-score is all the way to positive. So it's actually more than one standard deviation away. And I can get it less than one standard deviation away, and then back to the negative side. So just looking at these z-scores, you can tell I have a point at 2 points that are below the mean, and I have 3 points that are above the mean because they have positive standard deviation scores. Which one's the furthest away from the mean? Well, based on the z-score, it looks like point A is the furthest away from the mean, and then point E, which kind of makes sense based on the picture. So let's take a look at this example. We've got 2 graduating college seniors receiving job offers. Now they're going to have different salaries because one is a marketing major and one is an accounting major. How could we compare their job offers if we know the average starting salary for both majors as well as the standard deviation? I probably should say the mean starting salary. We also use average a lot. So the way that you could say, oh, let me look. Okay, the accounting major is getting $1,750 over the mean. Oh, he must be getting the better offer because this guy's only $1,500 above the mean. But let's take a look at it according to z-scores. So the accounting major z-score, we're going to take the job offer minus the mean, all divided by the standard deviation. We're going to do the same thing for the marketing major, 4,000 minus 42,500 divided by 1,000. When we calculate these, we're going to find that the accounting major has a z-score of 1.167, and the marketing major has a z-score of 1.500. Both have above average job offers, but believe it or not, the marketing major actually received the better offer because that offer was 1.5 standard deviations above the mean instead of 1.167. So now you're going to take a try at calculating the z-score, and here we have a table that gives the mean and standard deviation of reaction times in seconds for two different stimuli. Here's stimulus 1 and stimulus 2. Your reaction time is 4.2 seconds for this first stimulus. So you can see you are below average. You're fast. Below average is good here, okay? And then stimulus 2, wow, you look like you're twice as fast, 1.8 seconds instead of 3.6. So both of these are 1.8 seconds below the mean. But which one is actually a little faster compared to other people? And here's the hint. You want the most negative z-score because you want to be lower than the average. So in that case, you can see the answer you should check. You should find out that stimulus 2 is the most negative z-score.